Today we're going to be taking a look at orthographic projections. Okay, orthographic projection is a two-dimensional representation of a three-dimensional object. Here, for example, is a 3D representation of a part. Here is the 2D orthographic projection. An orthographic projection represents different sides of an object. For example, here is the front side, the top, and the right side, and here's where the projections would be, an orthographic projection. There are 6 principal views that can be created looking at an object straight on at the direction shown over here. Here is the front, the bottom, the right, the rear, the top, and the left side. The glass box method. How do we create the 6 principal views? The glass box method. The object is placed in the glass box. The sides of the object represents the 6 principal planes. The image of the object is projected onto the sides of the planes. Okay, notice the projection planes. These are the planes here. Notice the front view, the right view, and the top view are the 3 projection planes that we had in Inventor. This is where we'll be drawing. Okay, notice how everything is projected, okay, from the original object. Okay, also notice too that if you're looking at something on an angle like B here, when you look at a top view, that will not be its true length right here. Okay, that will be foreshortened. The box is then unfolded to give us our 6 views. Okay, label the 5 remaining principal views with the appropriate view name. Okay, what is this view? That is the top view. What view is that? Right. Rear. Left. And bottom. Okay, those are our 6 principal views. Okay, what are the differences between the right side and the left side? Okay, the only difference is they are mirror images of each other, but here, for example, this edge right here is shown as a solid line. Over here it is shown as a hidden line. That means that you cannot see it there, it's actually hidden. What are the difference between the top, bottom, and front and rear views? Same thing. If you look at the front and the rear, they're the same. They're mirror images of each other except for the hidden lines. Okay, same for the top and the bottom. Okay, which view has the least amount of hidden lines? Or which views? Well, that would probably be the front, the right, and the top. Which view has the least amount of hidden or dashed lines? I think I just said that. Okay, the standard views. When constructing an orthographic projection, we need to include enough views to completely describe the true shape of the part. Okay, the more complex, the more views we're going to have. The simpler the part is, the less views. It's very important to make sure that we include enough that it is easy to understand what the object looks like. Okay, that is our goal in life. We want to make sure that people can look at our drawings and tell exactly what they are. Views in orthographic projections are the front view, the top view, and the right side view. That is what we normally use. The remaining 3 views usually don't add any new information. Now, as everything we'll talk about in this class, there are exceptions, and we'll talk about some of them later. Okay, how many views do we need to completely describe a block? Okay, we really only need two views. Okay, here are our three views. Here's the front view, the right view, and the top view. Okay, notice with a block we have three dimensions. We have the height, we have the length, and we have the depth. Okay, just looking at the front view and the top view, we can dimension the height, the length, and the depth. The right side view has the height and the depth, but they're already covered. Okay, we can put this view on, it will not hurt anything, but we really don't need to, and we definitely would not put the dimensions on there. How many views do we need to completely describe a sphere? Yeah, that would be one, the diameter, and that is it. The front view shows the most features or characteristics of the object. It usually contains the least amount of hidden lines. The front view is always chosen first, and the other views are based on the orientation of the front view. Okay, the views must align. The top and front views are aligned vertically and share the same width dimension. The front and right side views are aligned horizontally and share the same height dimension. Very important that they line up. Okay, so here for example, here is the front view. We have the height and the width. Okay, the top view has the width, or shares the width. The right side view shares the height. Line types used in orthographic projection. Line types and line width provide information to the print reader. For example, line types and weights can be used to answer the following questions. Is the feature visible or is it hidden? Is it part of the object or dimension? Is the line indicating symmetry? There are four commonly used line types. There is continuous, hidden, center, and phantom. Some lines are more important than others. Importance is indicated by line weight or thickness. The thicker the line, the more important it is. Visible lines. Visible lines represent the visible edges and boundaries. They are continuous and thick. They are very important lines. Hidden lines represent edges and boundaries that cannot be seen. They are dashed and medium thickness. Which of the following do you think is a visible line? That is correct, the one in the middle. Which of the following is a hidden line? That is correct, it is dashed lines. Center lines represent axis of symmetry. They are a long dash, a short dash, and they are thin. Phantom lines are used to indicate imaginary features. Okay, so they can use to show alternate positions of moving parts, adjacent positions of related parts. The line type is a long dash, a short dash, a short dash. The line weight is usually thin. Okay, which of the following is a center line? That is correct, the one in the middle. Which of the following is a phantom line? That would be the one with two short dashes. Break lines. Breaks are used to show imaginary breaks in objects. A break line is usually made up of a series of connecting arcs. The line type is continuous and the line weight is usually thick. Which following is a break line? It would be that one. Okay, notice how the different line types are used. Here are hidden lines. Okay, visible lines. Center lines. This is a cutting plane line. It is a phantom line, but it is made thick. Here are section lines. Section lines too are thin lines. Identify each of the line type that is pointed to and the associated feature of the selected lines. Okay, so what type of line is this right here? That is a hidden line. What type of line is that one? That is visible. What type of line is that? That is a center. What is this associated feature? So which letter does that associate with? Okay, that would be C down here, where if you took this object, flipped it, and looked at the top, this line here would be hidden. You wouldn't see it. Okay, how about this line here? Okay, that would be the hole here, or the circle. Okay, how about this feature here? That would be B, and that would be this line here. Again, if you took and flipped this and looked in this right-hand side view, that would be shown as a hidden line, as would be the hole through it. Rules for line creation and use. Following rules will help us create lines that communicate efficiently. Caution, due to computer automation, some of the rules may be hard to follow, and they will be. Hidden line represents edges and boundaries that cannot be seen. Creating hidden line, the length of the hidden line dashes varies slightly as the size of the drawing changes. Okay, so there is no set length for the hidden line. Rule number 2, hidden lines always begin and end with a dash. Okay, not a space. Exception when the hidden line begins or ends at a parallel, visible, or hidden line. Okay, like here, this is going behind here, so it would start at the space so you can see that it is going through this particular line. Same here, you'd leave a little space there so that you can tell where this visible line ends and where this hidden line begins. Dashed lines should join at the corners. Center lines. Center lines represent axes of symmetry. Okay, you normally see it on round objects, but it doesn't have to be. Okay, this is not necessarily a rounded object. We can't tell from this drawing, but we know that it's symmetrical on either side of the center line. Okay, again, center lines represent axes of symmetry. They're important for interpreting cylindrical shapes. If you look at this right side view, it's hard to tell what it is. Okay, if we put a center line through there, we know that it's the center of this circle. They're also used to indicate circles of centers and paths of motion. This is a bolt circle. This shows that this moves along this path right here. Creating center lines, rule number 1, center lines should start and end with long dashes. Center line should intersect by crossing either the long dash or the short dash. Center line should extend a short distance beyond the object or the feature. Okay, the center line wants to go beyond the feature, it doesn't want to go here. Okay, if you end it here, it's hard to tell where the center line and the visible line start and end. Center lines may be connected within a single view to show 2 or more features. Okay, center lines should not extend through the space between views. Okay, this is one view. Okay, so we can join these center lines together. If we had another view, a right view over here, that center line here would not extend over there. Phantom line uses. They may also be used to indicate adjacent positions of related parts. Here is a part that you might want to show on your drawing. Maybe it's an assembly drawing, and the part's not really there, but you need to show the way that it lines up. Used to indicate repeated detail, you have something like this spring here, or you might have 20 or 30 of these coils here, and you save time and ink and money by just putting the phantom lines there, showing that this is repeated over and over again. Also used to show a change in surface direction produced by fillets. We normally don't do this unless we have an object like this. Okay, sometimes when we have fillets, it is hard to view or see what they are. Many times we leave those lines off. They're used to indicate alternate positions of moving parts. Okay, notice so here is a phantom line showing where the part would move to. Here is a center line showing the movement. Phantom line should start and end with a long dash. Break lines are used to show imaginary breaks on an object. Again, if we have an object that's very long, and this is just the same thing, just a long stretch of it, we can put a break line in there. Two types of break lengths is the distance to traverse is short. Okay, we use connecting arcs. Okay, kind of like this one that we showed right here. If we have a long distance, okay, we use a thin straight line with a jog. If two lines occur in the same place, the line that is considered to be the least important is omitted. Lines in order of precedence are the cutting plane line, then the visible line, then the hidden line, and then the center line. If you had all four of those right on top of each other, you would only see the cutting plane line. If you had a visible, hidden, and center, you would only see the visible. If you had a hidden and center, you would only see the hidden. Lines used in orthographic projection examples. Okay, we can fill in these dotted projections to show what lines we have there. Okay, usually we draw the visible lines first. Okay, then we draw the hidden lines, and then the center lines. Okay, notice the small dashes cross in the middle. Notice the center line connects between the features in the same view right here, but it does not connect here. Creating an orthographic projection. Okay, first thing here, we would choose a front view. Which view shows the most about the object? Okay, that would be view C, that we would pick that as our front view. Okay, we decide how many views we need to have. Okay, how many you think we should have and what views. Okay, we need two. We need the front and the top. Okay, we will continue this example by showing all three standard views. Okay, so we draw the visible features of the front view first. Here is the front view. Okay, then we can draw projector lines across and up. Okay, then we can draw the top view. Now remember, these lines must line up exactly. Okay, and we can put our hidden lines here. Okay, we then draw a 45-degree angle from where this line and this line meet. Okay, then we can project these lines, everything from this top view until it hits that 45-degree line. And then it comes down. We draw our projectors over from the front view. Then we connect all the dots here to have our right-hand side view. So there they are. Okay, draw any center lines that we need to draw. Okay, so remember, these are adjacent views. These are related views. Okay, remember that this width right here is the same as this here, and if we draw a 45-degree angle in there, that will do that automatically for us. Okay, here is the completed drawing. Okay, we use different types of projections depending on where you live. In the United States, we use what is called the third angle projection. In Europe, we use the first angle projection. Okay, here is the third angle projection. Okay, if you look at the front view, the right side is looking in on the right. The left is looking in on the left. The top is looking down on the top. The bottom is looking up at the bottom. Okay, kind of makes sense. First angle projection, notice the difference in the views. Okay, in the first angle projection, to look at the left view, we look inside, we look towards the right. Okay, notice that the top view, we're looking up from the bottom. Okay, I find first angle projection to be very, very confusing. We will not ever, in this class anyway, draw any first angle projections. Okay, we set this automatically in our CAD program and it will take care of that for us. Okay, which orthographic projection uses the first angle and which uses the third? That's the third, that's the first. That's the third, that's the first. Okay, applying what we learned. Missing lines. Fill in the missing lines in the front, right side, and top view. Okay, there is one missing visible line in this view here. Can you find it? Okay, it is, whoops, it is this line right here. The right view has one missing visible line and two missing hidden lines. Okay, here is the visible line, this edge right here. The hidden lines are this cutout right here, which is looking in here. So if we're looking in this side right here, okay, we see that line there, that's that first visible line. This line here, which is hidden, and this line coming up, which is hidden. Top view has 5 missing visible lines and 2 missing hidden lines. Okay, again, looking down on the top, you would see this line, you would see this cutout, and you would see this line here. This little notch down the bottom will show up as hidden lines. Shade in the surfaces that will appear in the front, top, right side views, estimating the distances, identifying the surfaces. Okay, shade in the surfaces of the front view. Okay, here is the front view. Okay, here is drawing the front view. We bring the horizontal and vertical projectors over. Here is the right side view. Okay, notice that between these we have a 45-degree angle. Bring these lines over. Here is the top view, which is the green section here. Identify the best choice for the front view. Okay, the best choice for this would be view A. Here is A looking in the front, here is B looking in the side, here is C looking down from the top. Okay, the assignment is going to be drawing an orthographic projection. There is a video on that, and that will do it for this class.